Throughout our journey of learning NLP, LLM and GenAI, we have made significant progress. In this video, we are going to delve into understanding the different types or variants of these LLMs, like what is foundational LLM, fine-tuned LLM and instruction-tuned LLM. So let's see. Let us try to understand the base or foundational LLM and fine-tuned LLM with a real-life analogy. Imagine a general practitioner doctor, someone who has completed their MBBS and is knowledgeable about a wide range of medical topics. This doctor is like a base LLM. They can handle various health concerns, provide general advice, and understand common medical issues. Think of the base LLM as a very smart person who has read a lot of books, entire information from internet, and knows a vast amount of information about the world in general. They have learned general facts, grammar, and language rules from various sources. So if you ask them a question or give them a topic, they can provide a decent, well-informed response based on their broad knowledge. Now, consider a specialized doctor like a orthopedic or a surgeon or a cardiologist. These doctors are similar to fine-tuned LLM. They started as general practitioners like the base LLM, but they underwent additional training and education to become highly skilled in a specific area. For example, an orthopedic surgeon becomes an expert in bone and joint related issues, and a cardiologist specializes in heart related conditions. Similar to this, these specialized fine-tuned models like ChatGPT, Google Bard, and Microsoft GitHub Copilot is specialized for different tasks. So in this analogy, the base LLM is like a general practitioner with a broad understanding of medicine, while the fine-tuned LLM is similar to specialized doctors who have received additional training to become experts in specific medical domains. So with this real-life analogy, we understood that there are two distinct categories of these language models: the base or the foundational LLM and the fine-tuned LLM. The fine-tuned LLM can be subdivided into task-specific fine-tuned LLM and instruction-tuned fine-tuned LLM. The former is tailored for specific tasks, while the latter is designed for general purpose or to cater to multiple tasks. Let's go further deep and understand the overall process of how they are trained. Let us try to develop some intuition about how foundational large language models are generated. We need to define a task. So here the task is to train a LLM to predict the next token or word in a sequence of text. Most of the foundational LLMs are trained for this task. Training data source. The foundational LLM is trained on a diverse range of text data from books, articles, websites, and other rich text content available on the internet. To give you an example, GPT-3 was trained on about 500 billion words or subwords or so-called tokens. Training data. The training data for foundational LLMs are prepared at token level, where tokens represent either words or subwords depending on the chosen tokenizer. The concept of tokenization is explained in a separate video, and a link is also shared in the description of this video. Now take one sentence as an example from the whole internet corpus, like cat is a pet animal, and try to prepare the training data for foundational model. When input word is cat, next word in the sequence is. When the input word is cat is, next word in the sequence is a. Similarly, when the input word is cat is a, the next word in the sequence is pet. And when input word is cat is pet, the next word in the sequence is animal. You can imagine the entire internet data is converted like this for training a foundational large language model. Then training objective. The primary objective of training the language model is to enable it to accurately predict the masked tokens within input sequence. By learning the underlying patterns and relationships in the training data, the model develops an understanding of language structure and semantics. When training is done, you have your foundational model ready, which you can use for inferencing. During inferencing, the trained model takes a sequence of tokens as an input and predicts the next token in the sequence. For example, given the input sequence cat is a, the model may generate the prediction cat is a pet animal, demonstrating its ability to generate coherent language sequences based on learned patterns. So in summary, these foundational models are very powerful in understanding the nuances and intricacies of human language. And when you input some incomplete text, it will utilize its learning through weights or parameters from its memory and attempts to complete the sequence or sentence. So this is how the foundational LLM or base LLM are produced. To imagine how powerful these foundational LLMs are, let's explore the white paper published by OpenAI for their GPT-4 model. So GPT-4 exhibits human level performance on the majority of these professional and academic exams. Notably, it passes a simulated version of the uniform bar examination with a score in the top 10% of the test takers. It is just unbelievable. Now you can imagine how powerful these foundational models are. I hope you get a good intuition about the foundational model or base LLM. Let's move to the next LLM types, which is fine-tuned LLM. Let's explore the concept of fine-tuning a large language model to build a better understanding. To begin with, let's establish a compelling fine-tuning objective. Imagine you are part of a research organization where your company utilizes various chat applications for internal communications among team members. The company is considering developing an application capable of summarizing these conversations automatically. Initially, the straightforward option might seem to be leveraging a third-party LLM platform. This approach involves simply calling their API, sending the chat conversations, and receiving the summary as an output. It appears to be a quick and easy solution. However, there is a significant drawback. Your management has raised concerns about the security of sensitive chat data. Consequently, they have decided against exposing this confidential information to third-party APIs. In response to this challenge, the alternative available is to undertake fine-tuning of a pre-existing LLM and develop a proprietary solution. You need to prepare your training data. This training data is supervised or labeled data. This means it has input and expected output. Let us see in detail how this training data would look like. This is just a few samples to develop your intuition about how training data will look like for this case. There are two samples. Each sample has conversation X and summary Y. You will have many more such samples prepared for fine-tuning the foundational model for this task. So we saw how the training data for this task would look like. Fine-tuning involves training the LLM on a specific task. So now your training objective is to learn the pattern from these training samples and build on top of your existing knowledge of foundational model. The training will produce a fine-tuned model. Let's call it my chat summarization GPT. Now you can test your fine-tuned model on unseen data and verify the accuracy. So by fine-tuning the language model in-house, the company retains control over data privacy and security, ensuring sensitive information remains within the organization's boundaries while still benefiting from the advanced capabilities of modern language models. Very well. I'm sure you got some good intuition about fine-tuned LLM. Let's move further and build similar intuition about instruction-tuned model. Let's explore the concept of instruction-tuned language model to develop a deeper understanding. To start, let's define the context for instruction-tuned language models. Imagine you are part of a tech company and want to develop a language model which can understand the user instruction and respond accordingly. This means if user asks this model to solve math problem, it should solve math problem. If user instruct this model to write software code, it should write software code. And if user asks to write story, it should write story. In a similar manner, if user asks it to summarize a topic, it should summarize. So basically, it should be just like an obedient human which follows your instruction. This means you need to build an instruction-tuned language models. This involves fine-tuning a pre-existing foundational language model with specific instructions or guidelines tailored to a particular task or domain. You need to prepare training data for instruction tuning. Training data may look like this. It contains instruction and expected response. Let us see this training data in more detail. On Hugging Face, under Dataset, you can have a look at this data, which is instruction-tuned data. It has instructions in one column and corresponding response in another column. There are instructions for solving math problems, instructions for writing summary on a topic, chat conversation, writing poems, question answering system, and many more NLP task related instructions. I have given the link of this instruction tuned data on Hugging Face. You can just explore this dataset to get more deeper understanding of how instructions tuned data look like. So we understood how the instruction tuned data look like. By fine tuning the language model with such instructions, it learns the patterns and prioritize and generate responses that align with the desired task objectives, and you get an instruction tuned language model. Now during inferencing, if you provide an instruction, say answer the user question based on the information available in this context, if answer is not available in context, say I don't know, and then you are providing the question and the context. Then this instruction tuned LLM will provide you a response based on the user query and the context you are passing. In this case, this instruction tuned LLM is equipped to effectively address many natural language model tasks based on user instruction. Great. So I hope now you have very good intuition about foundational LLM, fine-tuned LLM, and instruction-tuned LLM. Based on the knowledge we gathered so far, if you find the prospect of constructing a large language model daunting due to its inherent complexity, cost, and time-intensive nature, your concerns are valid. However, there is a good news. You don't have to embark on this journey from the ground up. You won't need to pre-train a new foundational model because various companies and open source communities have already dedicated significant resources to developing and continuously refining these models. They have made the results of their efforts readily available, sparing you the need to start from scratch. In most cases, you will begin with an instruction-tuned language model, which is either accessible through open source platforms or paid services. You have two options here. For paid providers like OpenAI or Google or any other, you can utilize their services via their API. You will pass your data and instructions to the instruction-tuned model, which is designed to understand user prompts. These prompts fall under the realm of prompt engineering. Alternatively, you can work with open source models. Here, you can download the instruction-tuned model to your local machine and work with it. Of course, you will need robust hardware that meets the requirements. The uses remain the same. You pass your data and instructions to the instruction-tuned model, which understand user prompts. There are various techniques and approaches when working with instruction-tuned model, such as in-context learning. Options like one-shot, few-shot, chain of thought techniques can be utilized for in-context learning. Another technique called retrieval augmented generation RAG. Using this technique, you can incorporate your domain specific data and develop domain specific use cases. If the above options don't meet your needs, you can explore the next option, which is fine-tuning a foundational model. As explained earlier, this involves choosing a right foundational model, then preparing labeled training data or fine-tuning data, and then fine-tuning the model. Let us move further and explore the foundational model, fine-tune model, and instructions tune model available through paid services and also through open source communities. For foundational model, I have here Mistral 7B and Llama 2 7B, 13B and 70B models. They are open source models, and Mistral is from Mistral AI and Llama is from Meta. On the paid services, we have foundational models from OpenAI and Google. Similarly, for task-specific fine-tuned LLMs, we have again from Meta and Google. And for instruction-tuned LLM, we have some open source options available here again from Mistral and Meta. And then, of course, from the paid services available from OpenAI and Google. You can also check on Hugging Face Model Hub. There are numerous LLM published with model card. You can click on the models. You can find details like about the models, comparison results with other available models of similar parameters, and steps how to use those models and etc. There is also an open source LLM leaderboard. The open source LLM leaderboard aims to track, rank, and evaluate open source LLMs and chatbots. If you have completed this video till here, then I believe you have done a good job in understanding LLM types and what are available in the market to explore. In the next video, we will talk about the different approaches when it comes to using these LLMs for your actual project and use cases.